Okay, so we will be studying the version 1 architecture, and we will understand the messages that are used to communicate between the agent and the manager. So before I start with actually the version 1 architecture, yesterday we had just finished with the organization model, and there was a proxy server present in one of the organization models. So the proxy server was included when I have a non-SNMP managed object. So continuing with that, an example, a real example of a network scenario. Just I'll read the slides, you will understand. This, see, if a proxy server organization model, if that topic is just separately asked, then you have to explain this scenario. So suppose we may want to manage an outside plant and customer premise equipment for an HFC, that is your hybrid fiber coaxial access system, in a broadband service to your home. So there are amplifiers on the outside cable plant which do not have an SNMP agent built in them. The outside cable plant might use some existing cable technology and has monitoring tools built into it, as for example, the transponders that measures various amplifier parameters. Now, this information from these amplifiers, we can transmit it to a central location using the telemetry facility. So this is the scenario of the system. Now, what we can do is we can have proxy servers at the central location that converts the data into a set that is SNMP compatible, and it communicates with the SNMP manager. So in the central office, I have an SNMP enabled system, but outside the plant or at the customer premises, I might have some other system where the SNMP is not present. Okay, they might use some other monitoring tools. Okay, so that data that they are collected, okay, so it goes to a proxy server. So I might have a remote site. So from a remote site, that data, it goes to a proxy server. That proxy server will convert that data into an SNMP compatible format, and it will communicate to the SNMP manager. So in this case, I require a proxy server organization model. So before we actually start with the architecture, so as a recap, if I want to say SNMP in one slide, so I have a manager, I have an agent. The agent is handling all these network equipment. So it can be softwares, it can be the switches, hubs, servers, or PC. Now, how this management is done, it is done using three things: internet management that we have seen. It is done using SNMP, MIB, and SMI. So what is SMI? It is the common organization structure for management information. I have a lot of management information. How will I structure it? So that is your SMI. Then what is your MIB? One naming space for all objects. Okay, so all objects jo hum naam denge, that is present. Okay, so that is in the form of a tree diagram that is we have seen. So that is your MIB. And then the communication protocol that we are using, it is your SNMP. So remember, SNMP is a communication protocol used for internet management. Many times students feel SNMP and internet management is same. No, internet management is the main thing. SNMP is one of the protocol used in internet management, and it is actually a communication protocol. I hope at least the idea what is SNMP and what is internet management is clear. So now let us see the SNMP architecture. Now, when I say just in the beginning, SNMP architecture, I mean it is the SNMP version 1 architecture. If you remember the OSI architecture, if you had drawn it in your book, you will feel that it is somewhat similar. Okay. But the messages are different. So I have the SNMP manager. So please draw it. Then I will explain. I'll pause for a few minutes. Okay, so I have the SNMP manager. You can draw at least the one side, and the remaining side you can just draw this arrow. No need to draw this. And why I'm telling you to draw, because definitely you will try to fit the 7 layers of your OSI. ये OSI model नहीं है और ये OSI layers भी नहीं है. Okay, so Internet, if you're searching the answers, you might get different versions also. जैसे SNMP का version है, answers भी वहाँ पे अलग-अलग है. Okay, so this is the correct diagram of architecture of SNMP version 1. So that's why I'm telling you to draw. Okay, so I have the manager, I have the agent. So the application, SNMP manager application is running in the application layer. This is the communication network. So whether it is wired or wireless, we are not bothered about it. Here we have the UDP, IP, data link, physical. Now, what is all this? I will tell you. ये physical layer नहीं है, data link layer नहीं है. Okay. And what is SNMP layer? ऐसा तो कुछ layer नहीं है. Okay. So please draw it because that is how you will explain the architecture. So here you can see now we have 5 messages from the manager. So the message is get request, get next request, set request, get response, trap. Now G or R, get request, capital hai, you have to write it in that way. You cannot just write all in small or all in caps, okay, or G in caps and R in small. No, you have to write it in this way. That is why I'm telling you to write. Get next request. So get ka G capital, next ka N capital, R ka, because this is how the syntax it will take. Otherwise, the ASN1 coding will not take this keywords or the message. Then I have set request, SNR is capital, and remember there is no space in between. Get response, trap. Okay. See, or trap word was not there in the OSI architecture, and sabke aage M tha in OSI. Here there is no M. Okay, so if by chance OSI and SNMP comparison is asked, okay, so please remember SNMP, you will obviously go with SNMP version 1 only. You will not take all SNMP version with OSI. That is not possible. So OSI and the first version of SNMP that you can compare. That way you will compare. So you can say it has 7 messages, it has 5 messages. Okay, and what are those messages? You need to write those messages. Here when I say the arrows, so get request, get next request, set request, these 3 messages are generated by the manager. That's why the arrow comes downwards. From manager se generate hoke agent mein ja raha hai. So it is unidirectional going down and it is received by the agent. So that's why this arrow is up. The remaining 2 messages, that is the get response and trap, is generated by the agent process. So it's the arrow is in this way and it comes from the agent and it goes towards the manager. So yahan se arrow niche or yahan se upar. Don't just put bidirectional. Examiner ko jo samajhna hai samajh jayenge. So if you put all these clause, the examiner will not give you marks. पर ऐसा मत सोचना कि जैसे last time हुआ है, I might be correcting your subjective part. University might give a clause, download it in a folder, send it to the cluster college. Okay, so we are 5-6 colleges in a cluster. Okay, so IA we handled internally, but might be the subjective part. They might tell you send the paper to the other cluster college. Okay, so I might not be checking your answer sheet also. That can be also. Okay, so continuing with the explanation now, I hope the diagram is there because this was the full screen diagram. In all the slides now, the diagram will be less, but the size will be small. So you have all these names. Now, why all these names? Or please see, it is a box present inside. As a through and through nahi draw kiya hai. So I expect that you are also drawing it in that way. Okay, so what is this architecture explaining? So it portrays the data path between the manager application process and the agent application process via 4 transport protocols. Okay, so those transport protocols are your UDP, IP, data link, that is your DLC, and the physical layer protocol. So these are not the OSI layer. These are the 4 transport protocols that I am using for the communication between a manager application and the agent application. So these are the 4 transport protocols that are present. this is not the physical layer, layer protocol that is present over here, and the physical layer is separate. We are not bothered about that physical layer. Now we have the 3 application layers. So this is my transport layer yahan pe ho gaya pura, because these are the transport layer protocol. Now the layers above the transport layer, so those are the 3 layers. So those layers are integrated into this SNMP process. So when I'm writing SNMP over here, so this SNMP has all the above 3 layers, that is the application, session and presentation layer. That is all 3 integrated in this particular layer. See, so we expect all these explanation when you are answering the architecture. Now we are talking about internet management. So the internet is only concerned with the TCP IP suite of the protocol and does not addresses the layer above or below it. So thus the layer 1 physical and layer 2 DLC in the transport layer can be anything of the user's choice, because they are just bothered with the TCP IP layer. Okay, so physical layer, data link layer, so we are free to choose anything. So in practice, the SNMP interfaces to the TCP with UDP as the transport layer protocol. So when I say which transport layer protocol is used for SNMP, this is a very common question that is asked for Viva. So please remember, it is the UDP protocol, and that too there is a specific port number at which this SNMP message goes and it comes. Okay, so that port number I will tell you later. Agar hum log practical kar rahe hote, to we would have set that port number, because if one of my device I'm setting it as manager and one of my device I'm setting it as agent and I'm communicating it, I have to give the port number. Okay, so it is the UDP port and there is a specific number. So while I'm setting the port address, I have to set that only. Otherwise, SNMP communication is not possible. So that's why I highlighted it with a red color. So you please remember, the transport layer protocol that is used by SNMP is the UDP protocol. So I hope you understood ki ye SNMP has all the 3 layers integrated together. These are the transport layer protocol. The internet is only concerned with the TCP IP protocol. The remaining last 2 layers, jo physical or data link layer, can be anything of the user's choice. Continuing with version 1. So as the name implies, SNMP protocol has been intentionally designed to be simple and versatile. This surely has been accomplished as indicated by its success. Yes, why? Because that is the current standard which is widely used. It is the industry standard. Internet management is also done using SNMP. So that's why, seeing the current statistic, we can say that it is actually a success. So OSI actually was never implemented. Okay, so communication of management information among the management entities is realized through exchange of just 5 protocols. In OSI, we had 7. Here we have 5 protocols. Now, so these are the 5 protocols: get request, get next request, set request. Okay, so out of these 5 protocols, 3 of these, so these are the 3 which I have already told, that is the get request, get next request, and set request. They are initiated by the manager application. So that's why the arrow is down. The other 2 message, that is the get response and trap, they are generated by the agent process. Okay, so now these are the messages which are generated. Now, what is the term that we actually use is an event. Okay, because this word will come later on also, event management. Now, what is an event? Whenever a message is generated either by the manager or the agent, we say that an event has occurred. Okay, so in this syntax, an event has occurred means either a manager has generated a message or an agent has generated a message. So in the SNMP management scheme, the manager monitors the network. So how is the manager working? He is monitoring the network by polling the agent as to their status and characteristic. Like suddenly you are sitting and you want to check the connectivity of the server, you type a ping message. Okay, so this pinging, you are not doing it continuously. So suppose the manager wants to check the connectivity. This is just one example I'm giving you. So what he will do, he will poll the agent. So he will send a request to the agent. Ki, "Arey baba, mujhe batao ye counter ka value kya hai? What is the statistics? How is the performance of the network?" And the agent will reply to that particular. So polling, I hope you know what is the word polling. So I send a request, I get a response. So in short, I call it as a polling or a poll. Now, this is in normal operation. It happens. The manager asks for something and the agent replies. Now, I can increase the efficiency of management by involving the agent in the management process. Now, how I can do it? It is by the means of an unsolicited alarm message. Now, this unsolicited message, again, this word I'm using many times. Unsolicited means मुझे किसी ने मांगा नहीं, मैं सामने से दे रही हूँ. Okay, so the manager has not asked for that any message or any data, but the agent is sending some alarm or notification to the manager. ऐसा ऐसा कुछ तो हुआ है. You need to take action. So these messages are called as trap. So in internet management or SNMP management, we are using the word trap for these unsolicited alarm messages. For OSI, we are using the word notification. Agar comparison aaya, so these are the points. Finally, it is an unsolicited alarm message only, but the names are different. So what is a trap? So trap aisa kuch alag mat sochna. So trap is the name of the message that we are, it's an unsolicited message that is generated by the agent. Now let us understand all the messages that are there in version 1. So the get request message. So the get request message is generated by the management process. What is that? So it is generated by the manager. So what get request? Okay, so it requests the value of an object. The value of an object is a scalar variable. Okay, the counter का कितना count हुआ है, switch का क्या condition है. Okay, so some performance statistics. So it is some scalar value. So the system group parameters are single instance values that are obtained using the get. Right now you will not understand system group parameter, but if you, I don't know, because people are not drawing or it's online class. जो MIB2 का जो tree था, the first group, वो जो 10 MIB2 was into 10 categories. I just project this diagram if you just remember. So the system group is the first parameter over here. Okay, so that is what we are talking about. Okay, so the system group parameters are the single instant values and are obtained using the get request messages. Okay, so system group parameters, matlab system wants to know the status of the traffic or congestion or packet loss or some performance parameters. So those are grouped under system group parameters and they are single instant values. So if I want to get those values, so I have to use the command get request. Now the next command is get next request. So from as the name, I have made one request and I'm making another request. Get next request is also called as get next. Okay, so it is very similar to the get request. Now you might feel कि अरे बाबा एक बार request किया वापस से request करने की जरूरत क्या है? Okay, but what is the condition is in many situations an object may have multiple values because of multiple instances of the object. So an example it is given. Suppose an interface has multiple addresses associated with a given row. Another example is the routing table of a router which has multiple values at every instant of a particular object. Router value, it keeps on updating at every instant. So abhi maine data bhej diya, zaruri nahi ki the same data is there throughout. Okay, so instantaneously or at every different point of time the value changes. So in that situation what I do is I have another message that is the get next request which obtains the value of the next instant of the object, not the current. पहला वाला तो भेज दिया, उसके बाद वाला value मुझे चाहिए. Okay, Okay, so that is why we have the get next request. Now it is important for you to understand. Abhi hi when I am telling you, अरे बाबा एक बार request किया, फिर दूसरी बार request कर रहा हूँ कि मुझे next instant का value डाल दो. So this was when we started with version 1. Might be we developed some mechanism where I, instead of having these two separate messages, एक ही मैसेज में I get bulk request. I can send a bulk request. बाबा मुझे 1 मिनट के बाद, 5 मिनट के बाद, 10 मिनट के बाद ऐसे सारा डेटा मुझे भेज दो. Okay, so I am giving you all these thoughts to think, because in version 2 में फिर हम क्या करेंगे? Okay, ये सब पांचों चीज से we were happy. From 7 we came down to 5. We were happy with these 5 messages and everything was working. But then एक बार request, वापस से request. Okay, so can we combine them in the next version? This is how the version progresses. Okay, so then we might have some messages later on in some of the version. We will see bulk request. Okay, so bulk request and then similarly bulk response. Okay, so in that case, instead of 2 messages, I have only 1 message to send a request. I hope you people are getting, because I'm not getting or not able to see anything at the other end. Then the next is the set request. Again, see, whenever you are explaining any command or message, please start with who generates that message, either the agent or the manager. Okay, so it is generated by the management process. When I say management process, means the manager. Okay, to initialize or reset the value of an object variable. The configuration parameters that are settable can be set using the set request message. Okay, so jo bhi configuration parameters I can set, which is in my domain, I can set using the set request message. Now the get response message. So the get response message is generated by an agent process. It is generated, remember, see this sentence, important. It is generated only on the receipt of get request, get next request, or set request message. I am not sending it on my own. Okay, so it is generated only. Get request bheja manager ne, then only I will send a response. Get next request bheja, then only I will send a response. Set request of the counter, agar he wants, I have to give an acknowledgement, ha baba change karo ye value. Okay, so on receipt of these 3 messages, I will send a get response message. So the get response process involves filling the value of the requested object with any success or error message associated with the response. We will see how the message looks. Okay, the get set request ka message kaisa dikhega, which are the fields, get response ka message kaise rahega. Okay, so that all will come later on. Right now, and just an idea of what is each message doing, and it's not ki aisa hi explanation hai. They will tell you to draw the message, set request, draw the message. Means the kaun sa field hai, kaun sa parameter hai, so you should know what are the variables that are present in the field. Jaise IP version 4 or IP version 6 ke tum log field draw karte the na, the packet header, how it looks. So similarly, but here it is simple. There is only one row, but you should know. Okay, so that we will study in details in the coming versions, because all these messages will be there and then little bit it will change. Now last message is the trap message. So the trap is generated by the agent. It is an unsolicited message. This word has to be there when you are explaining trap. It is generated by an agent process without any message or event arriving from the manager process. Okay, so it occurs when it observes the occurrence of a preset parameter in the agent module. It matlab when the agent observes the occurrence of a preset parameter in the agent module. For example, a node can send traps when an interface link goes up or down, or if a network object has a threshold value set for a parameter, such as maximum number of packets queued up, a trap could be generated and transmitted by the agent application whenever a threshold is crossed in either direction. Manager ko lag raha hai ki sab kuch normally chal raha hai. Okay, but the agent is the first one who is connected to the object or to the network element. So if he feels some unusual thing has happened, okay, and because he cannot take a decision, he cannot change a parameter. His work is to collect the data, monitor, and whenever the manager asks, he has to give that data. So agent को कोई role नहीं है यहाँ पे कि अच्छा अरे बाबा ये counter overflow हो रहा है, let me reset it. Okay, nothing he can do. So he has to notify the manager, and the manager has to immediately send some response. So that's why this trap alarm message is given to the agent, so that he can tell the manager, okay, something has happened and you need to take some decision. So these are the 5 messages. I hope these 5 messages are clear. Whenever you are explaining the SNMP version 1. Now, if you see the architecture, we have in the architecture not only 5 messages and the protocols, we have the database also. So the manager also has a management MIB. The agent also has an agent MIB. So please don't forget to draw the database. Manager के पास तो database था. In OSI, if you remember, only the manager had a database. In SNMP, the agent also has a database. We call it as the agent MIB. This is the management MIB. So the SNMP manager, which resides in the NMS, has a database that polls managed object for the management data. It consists of 2 sets of data, one on the information about the object, that is the MIB, and the second, what is the value of the object. Now, what is MIB? MIB is a virtual database and it is static. In fact, it needs to be there whenever an NMS discovers a new object in the network, and it is compiled in the manager during the implementation process. Continuing with the database, the second database that we are talking of, first one was a static database. The second one is a dynamic database, and it contains measured values associated with the object. This is the true database. So MIB has a formalized structure. The database containing actual values can be implemented using any database architecture chosen by the implementer. So no details have been given because we can choose that this particular database, which is having the actual value, by any of the vendors. Okay, so iska koi hamara details nahi hai. Now the SNMP manager has a database which is actually a physical database. Please remember, OSI mein agent ke paas koi data nahi tha. And if you see, the way in which they have drawn the database is also different. Students many times overlook this particular point. See, the way in which this database is drawn, the way in which this database is drawn is different. Now, what is the difference? Okay, so when I talk of the database which the manager has, it is actually a physical database. SNMP agent does not have a physical database. It is a temporary database, okay, which is present in the form of a software modules. जब भी ये मुझे डेटा मांगेगा मैनेजर, मुझे सिर्फ देना है, उसके लिए मुझे एक अलग सा फिजिकल डेटाबेस और स्टोरेज यूनिट बनाना नहीं है. Okay, both the MIBs which are there in the manager and agent are software modules only. Only thing, remember, this is actually a physical database. I will have a separately system which will store this. Here it is not a physical database. Okay, so it's a software which is handling that database in the agent application itself. So that's why we have drawn it in this particular way. So this completes your explanation of the SNMP version 1. In the next slide, which is actually I will not start because this is totally on a different section. So we finished the SNMP organization model and the system overview. We had seen the working of the system overview. Now we communication model we had seen, and the way in which manager and agent was communicating. हाँ, और एक चीज मुझे बोलना है, if SNMP version 1 architecture बोला तो you will be explaining the same thing. SNMP communication model भी पूछा तो it is the same thing which I explained today. So today's lecture question might be different, but you are explaining the same thing. So if SNMP version 1 communication model agar pucha, so how is the manager communicating with the agent using those 5 commands? And if SNMP version 1 architecture also, if they are asking, you need to explain the entire architecture, you need to explain those 5 messages. So please remember that communication model and architecture of SNMP, it remains the same. Now, what we are going to, I will not start, how much time is there? Let me see. 9 minutes is there, but I will not start it. What we will study actually is the communication model, which we have already studied, and the SNMP community. Remember when I was sharing the models, information model, communication model, organization model, functional model, the word security parameters came into picture. So SNMP, a manager can communicate to the agent using the community profile. So it's an altogether different topic, how communication takes place but in the community. Okay, so why we are making a community is just to involve the security. Abhi humne ye 5 messages dekhe. Okay, nowhere directly you can see that security was involved. इसने मांगा, इसने दिया, इसको लगा कि कुछ हुआ, इसने alarm भेजा. So it was all routine application which was happening. Okay, but security to hona chahiye in any communication system. Okay, the security is of utmost importance. So the same model we will revisit, not exactly again revisit or explain it, but by understanding the concept of SNMP community, you will understand कि security कैसे by default imbibed है. Neither there was any security protocol, nor there was neither the agent verified कि अरे बाबा ये सही मैनेजर ने मुझे रिक्वेस्ट भेजा है और मैं इसको डेटा भेज रहा हूँ. Okay, so directly it was not evident. Okay, but security is still present, so that we will understand using the community model. So the same model is present over here. So I will continue it in the next class. It's okay, and we will study more about the trap messages. Trap is an alarm that we are generating, but there are various kinds of traps. Okay, so that's again an important question, and we will be concentrating on the SNMP community. Okay, so this community is specifically for, so it's a whole new topic which I will cover tomorrow. I'm not starting because otherwise it won't finish. Then what is the SNMP package structure that we will study? Okay, so it's a simple package structure. So all these things are important from the viewpoint of Viva. So that SNMP packet का ASN1 coding किया हुआ है. अगर मुझे message भेजना है, how will I type that message? Okay, so the कैसे encapsulation होता है at each layer, that is also present. These are the ports which I was saying. The manager is there, the agent is there. It is using the UDP port. So which UDP port I will be using, it won't be there directly in the notes, but it is an important aspect. And then we will understand how the communication takes place. And these are the, I'm just showing you because I don't want to cover, but what is there. So this is the PDU structure, get request, set request, jo messages tha. So what is the PDUs? That is the protocol data unit. So these are all important PDUs that you have to remember. They will tell you trap read PDU draw karo. Viva mein bhi puchte and explain what is the PDU, but it is all important. So these are the types of trap. Trap is an important aspect when we are talking about SNMP. Okay, so these are all which I'll start from tomorrow. So tomorrow I will be starting with the SNMP administrative model, that is the SNMP community. So today I'm ending the lecture.